Ashley Pittman from Data Direct Networks. He's going to talk about performance tuning for Lustre. Ashley Pittman.
Thank you. So not only am I not David Vaser, I'm also not wearing a DDN shirt. So if the hotel laundry delivered any of you a DDN shirt yesterday, can I have it back afterwards, please? So I'm going to talk about building Lustre on a strong foundation. What we do to deliver Lustre to the large numbers of customers that we have. So I work in the in our solutions engineering team. What I do is I build and assemble the bits that we need to make and deploy Lustre, and then we have a team that goes off around the world and actually works on site with people to do that. There's a lot to getting Lustre together. It's not just DDN hardware and the Lustre RPMs. There's the OS and you know, lots of stuff is needed for the deployment, but also the monitoring. I mean, there's many different ideas that people have along that, and many different implementations. And one of the things about DDN is we deploy to lots of different environments, so we have to be very flexible in what we integrate with. So we've been doing this for 10 years. The first DDN hardware is over 10 years old. I just checked with Jeff a while ago. The first Lustre deployment was slightly under 10 years, but we've got an anniversary coming up there. I think he said it was one of the first 4 or 5 Lustre deployments, commercial Lustre deployments ever. So we've been doing this for a long time. The other interesting thing to note on this slide is that we still support systems going back to 2008. So not only have we been doing it, we've got a lot of experience, but we also have to maintain and support systems that were put in up to 5 years ago, which presents us with some challenges.
Systems from 2006.
Are you supported?
Yeah.
No one told me. Does it work?
Yeah.
Excellent. Then you're supported. Come and find me afterwards. I want to do a health check. A bit about our lineup. We've got the S2A 9900. You're possibly on something even older than that. That's a very good system. It's still on here because we still support a large number of these. I haven't looked at the percentages, but we deal with the 9900 every day. And any new deployment. So the Lustre 2X upgrade. Not only do we have to test it and benchmark it on the SFA, but we also have to do the same on the 9900. So it's not deployed for new systems in Lustre, but it is something that we still have to keep an eye on and make sure that we can apply updates to it and people can continue to utilize as they want to. There's a 6620, which has the dubious honour of being our smallest Lustre system. I looked up our database before I did this, and we have a Lustre system that consists of one 6620 and 4 OSTs. So I haven't put anything about scale in this talk because we deal with scale in both directions. Don't automatically assume that DDN is very high end. We also have to think about the smaller systems. There's the 10K, which is the first generation of the SFA product line. Lots of these out in the field. Currently still being shipped. Very interesting hardware. Brought the E platform on board. And then there's the 12K, which is the interesting one that everyone's excited about at the minute. I know a few of you have one. We have a couple. I got my own one last week, which I'm looking forward to doing some more destructive tests on that I haven't been able to do so far. And the interesting thing about the 10 and 12K, the 12K particularly, is the embedded. So the appliance. So what we're doing here is we're getting away from block storage and external servers and moving everything into the into the controller. It's been out there, it's been deployed for 18 months now on the 10K, but in the 12K is really bringing this to mainstream. So the 12K20, you'll see the product line in a minute, but the 12K20 delivers the same performance on, or very comparable performance on the embedded and the non-embedded. So we really think it's going to be very widely adopted. Here's just a little slide of how it's built. The outer grey box is a singlet. You have two of these per controller, obviously, and part of the singlet, the I/O bridge, the back-end SAS channels to the storage. Then you've got the RAID engine, the RAID processor, exporting virtual disks, and then the link to a number of virtualized VMs running Lustre, as you'd know and recognise, and then dedicated PCI HBAs per VM. What's actually interesting here is the OS that we put in the VMs is very, very similar to the OS that we put on real metal hardware. The only difference, I think, is the block driver and the StoneIF settings that we use for HA. So it's if you do have a 12KE or a 10KE, then the administration environment is almost indistinguishable from a more traditional configuration. The other benefit, or the major benefit of doing this, I guess, is less hardware. You've got less power, less hardware, less rack space, less weight, which I know is an issue for some people. Licensing can be better as well, and so we can just make a more dense system. Some of the very big systems I know are keen on this. This is the full product line that we're coming out with the 12K, the 12K20 block storage, the 12K20E, which is the most interesting one. We anticipate being the widest adopted, and the 12K40, which is the faster block storage. It'll be interesting to me to see how these are adopted relative to each other, but the embedded is the one that's generating the interest at the minute. There was the talk on the T10 Diff. That's next slide. So this is an interesting thing about drive rebuilds. What we used to find was that SATA drives would go offline and they would stop responding and fall out the RAID set, and we'd have to pull them out and do a full drive rebuild, which took 3 days. What we discovered was that when we tested these drives, often they were fine, and they weren't sick. They were just dead. They just deadlocked somewhere in the drive. So we've got a new feature. It's actually a hardware feature rather than a software feature that we've got in newer SFAs, where you can actually power cycle the drive, and this is fully automated now. So previously, when we learned that this was happening, we were at a stage where we could get in touch with the customer and say, pull the drive, reseat it, and see if it fails again, and 80% of the time it wouldn't. Now we've actually got the ability to do this, added the ability to do this to the hardware, and the SFA firmware does that for us. So our support calls for dead drives have gone down by 80%, and obviously the impact that has on rebuilds, we're not impacting the customers nearly so much there. So this is a talk about T10 Diff. The T10 Diff stuff is interesting. I think it's it's a good thing. End-to-end checksums are good. It's not just in the network where data gets corrupted. We've actually had we've solved the problems that T10 Diff set out to solve inside the SFA. I mean that's part of the benefit of the SFA, but we're still interested in sort of using the T10 Diff to extending Lustre and making sure that the SFA works with that feature if it comes online. So the key advantages of DDN. It's very reliable. We've done this for a long time. It's fault tolerant, multiple redundancy at every level. It's very performant. we've got a lot of experience testing it, a lot of experience in the fields, a lot of different configs, different sizes, different scales, different hosts. It's a headache for us, but we've seen an awful lot of different configurations. So I put this slide in. I nearly took it out because it was the same slide Kiefer's had, but I think it's really important to say how close DDN and WAN-Cloud work. DDN have a very extensive, very competent field team, #1 in the world, I think, there in terms of Lustre experts out in the field. We work very closely with WAN-Cloud. We're actually using the WAN-Cloud RPMs directly from their site now to when we do deployments, which is good news. So there's a very close relationship there. The DDN engineering team is involved in putting everything else together that you need to make Lustre work, and liaising with WAN-Cloud engineering when there are Lustre issues. And that's a very good relationship. Well, we certainly think so. We're interested in Chroma, obviously. A lot of people are. This is going to be a major step forward. We did a demo on our stand at Supercomputing, and if you catch me before the end of the lug, which I think is not so long now, I can do you a demo, but I can either do that today, or you can email me and I can arrange to do it in the future. We're looking forward to Chroma. We're working closely with WAN-Cloud to make sure that it works on our hardware. It's got a number of features that we're very keen on. The storage integration is the one that I'm looking on now, so adding very specific DDN storage statistics and metrics to the GUI. One of the things we're very keen on is that you should be able to click through and start from the overview of the file system and drill down through file systems and OSTs, and then get down to the RAID sets and the virtual disks and the physical disks. So you can follow, sort of trail, if there's a performance anomaly, you can sort of follow it through the whole trail and identify where it is. It also helps with drive failures. I mean, the notification aspect on this, if you get a drive failure, Chroma pops up. The storage integration allows Chroma to pop up and say there's a drive failure on this OST, which is quite a complex thing to get working internally, but is useful to know. DDN are also looking forward. We're putting a proposal to the Fast Forward project. We've got some assistance on WAN-Cloud in this, so we're putting in a thing there. Again, based around Lustre, possibly a different back end. We're looking at the OSD level, trying to make something scalable. There's the issue at the minute where if you look at the application, the application is dealing with a series of pieces of data per communicator or per rank, and at the storage level you've got a series of objects which currently are OSDs but might change to something else, and there's this sort of artificial POSIX layer in the middle which takes a series of objects here and a series of objects there and lays them out in one big long stripe and merges them between the two, and why not just go from object to object? So we've got an interesting proposal going in there. Okay, so the deployment challenges. What are the requirements for deployment? Well, it must be automated, it must be reproducible. If you can't reproduce it, how do you know you produced it correctly in the first place? It has to be simple. An admin that does anything you have to type more than 4 times on 4 different nodes, you make a mistake. Statistically, it's that level of that scale where you need to start automating things, and that's really very low. We're looking at systems from 2006, maybe. We need to know when things changed over that time, and we work with many different vendors, so we need to be flexible about different motherboards, different HCAs. And another key thing is it must be mutable. We have people come in and say, I bought this system 3 years ago, I've got a new cluster, I'm adding IB, can you leave the Lustre version as it is, but add IB to the existing setup. So we need to go back and be able to reconfigure a 4-year-old system with the original config, and just make small changes to it. So what's changed in the last 5 years? New versions of Lustre. Quotas are a big issue for us. New versions of the OS. As I say, NID changes, we get people changing those all the time. Hardware has been replaced, so you know, replacing the metadata server is not so difficult in 1.8. I don't want to think about it too much in 2.x. I can't remember where that came online, but I know it's a lot harder now. But also, what's going to change in the next 5 years? So systems we're putting in today, when we spec the hardware and when we spec the configuration, you know, what's going to happen? So DNE is very, very interesting. HSM are very interesting. You know, I can guarantee that the deployments that we're configuring now, you know, will be upgraded to have DNE. You know, do we need to you know, just allocate spare slots for that, or do we just worry about it at the time, which is probably not the thing to do. So there's a lot of things that we need to prepare our release for, in preparation for it changing. And I think that's all I have. So thank you for using DDN Exascaler.
All right, thank you, Ashley Pittman.